In this question, we have to prove that 5 cos 5a is equal to 16 cos raised to the power 5a minus 20 cos cube a plus 5 cos a. For doing this question, we'll be using these 5 identities which I have already written. And these are the identities we are going to apply. And let's see how can we proceed. First thing that we need to do is split this cos 5a. What I can write cos 5a as cos 5a as 3a plus 2a, right? And then we'll apply this first identity here, the one I have written on the screen. Now, as you can see that this can be written further expanded as cos a cos b, that is cos a dot cos 3 2a cos a cos b minus sin a sin b, sin a sin b. And in the next part, what we are going to do is to write this cos in terms of cos 3a, expansion of cos 3a. So cos 3a is equal to 4 cos cube a, 4 cos cube a minus 3 cos a, right? That multiplied by cos 2a, I'm writing cos 2a as this. This is 2 cos square a minus 1. Right? Now, next, in the next part, we are going to write sin 3a again using the expansion of sin 3a, that is in a bracket, this is 3 sin a minus 4 sin cube a, and sin, this is sin 2a, this is sin 2a. Sin 2a is 2 sin a dot cos a, 2 sin a dot cos a. Now, after that, we are going to expand this by applying the distributive property. So what we are going to get here, 4 into 2 is 8. So this is 8 cos raised to the power 5a. 4 into minus 1 is minus 4 cos cube a. And then this multiplied by this. 3 into 2 is 6. Cos a into cos square a is cos cube a. And finally 3 into minus 1 is positive 3 cos a, right? So we got this from the expansion of the first part. From the expansion of this first part we got, and we'll keep it. Now we are doing the expansion for the later part. For the later part, what we have to remember that we cannot, as you can see, our RH is in terms of cos, right? So we cannot write cos cube a, as we do not have a relation of cube sin cube a with cos. Once again, we need RHS in terms of, as you can see, RHS is in terms of cos, but this is sin cube a. So what we need to do is to take sine common from here and multiply that sine with this, right? You'll soon understand why we are doing so. So I'm taking a sine common from here. And so this becomes 3 minus 4 sine square a, and multiplying this sine to this. So what we'll get here, we'll get 2 sine square a dot cos a. Right. Why we did so? Because we can write now sine square a as 1 minus cos square a. For this part, this will be copied in every part, this section of this. And so I'm just keeping a do sign here, and I'm solving the other part. So as you can see here, when we open this bracket, right, before that, we need to convert this sine in terms of cos. So I can write sine square as 1 minus cos square a. Same we'll do on the other part, 2 into 1 minus cos square a, right? This sine square is 1 minus cos square a into cos a. Keeping this left one part as it is, minus, now for the some other simplification is just opening this bracket, minus 4 plus 4 times cos raised to the power 2 cos square A. And on this part, as you see, when you bracket will be open, it will be multiplied by 2 cos A. So this will be 2 cos A into 1 is 2 cos A minus 2 cos raised to the power 3A. We'll keep copying the left hand side part as it is, and then we'll do with further simplification. 3 minus 4. So I can write first 4 cos square A as it is, and 3 minus 4 is minus 1. And this will be copied. 2 cos A minus 2 cos cube A. Now, again, we will do distributive property, keeping this part as it is. And then if you multiply, as you can see, 4 cos square A multiplied by 2. So 4 into 2 is 8. This will give you 8 cos cube A. 4 cos square A multiplied with minus 2 cos cube A. 4 into 2 is 8. This is minus 8 cos raised to the power 5A. Now, when I multiply with minus 1, it will be minus 2 cos A and minus into minus, that is plus 2 cos cube A. That we got on this part. Continuing with the do sign for the first section. And then I can see some like terms here. So I can see this is 8 cos cube A and 2 cos cube A will give you 10 cos cube A, and minus this will be remain as 8 cos 5A minus 2 cos A. And if I open this bracket, as you know that the sign will get reversed. So that is what I'm doing. So I'm reversing the sign here. This will be minus, this will become plus, and this will become plus. Now check some like terms here for the final simplification. As you can see here, some like terms. Let's say if I, yeah, this is possible. Look into this. This is 8 times cos raised to the power 5A, right? And this is another 8 times this one, another 8 times cos raised to the power 5A. So it will give you how much? 16 times. So I'm writing here. That is 16 cos raised to the power 5A. Next, if I see the cos raised to the power 3A. So cos raised to the power 3A. You can see cos raised to the power 3A here. Right. This is cos raised to the power 3A minus 4 times cos raised to the power 3A and minus 10 times cos raised to the power 3A. So that will give you minus 4 and minus 10. So there is one term which is missing. Yes, that's right. This is actually, you can see this is minus 10 and this is minus 10 again, right? There's a minus sign. So that will give you minus 20 cos raised to the power 3A. And then what left here is 3 times cos A, and this is 2 times cos A. I will get 5 times cos A plus 5 times cos A, right? So this is how we got this RHS. What you need to do here is that what I have done exactly here is just simplifying, right? Using this identity and expansion to get this RHS.